Dun, dun, da, 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 da.
The objective of this experiment is to determine the spring constant of a spring by measuring the period of a mass spring system.
For this experiment, you're going to need a mass set, a spring, a ring stand, 2 rods, clamp, a motion sensor, a C-clamp, and a video recording device.
To set up this experiment, put the large rod in the ring stand and secure it to the table using the C-clamp. Then, using the small clamp, attach the small rod to the large rod. Place the spring on the small rod and let it hang. Then place the motion sensor directly under the hanging spring and connect it to a laptop.
To collect data for this experiment, attach a mass to the spring. Turn on the motion sensor and release the spring. Allow the spring to oscillate for a few seconds while the motion sensor collects data.
To calculate the K value from each trial, use the equation the quantity of 4 pi squared times mass divided by period squared. Input the data collected from the motion sensor to find K for each trial. Then average all the K constants found from each trial to get the experimental K value.
To calculate the spring constant using Hooke's law, you're going to need a meter stick, a Newton scale, and the same spring used in part 1 of this experiment.
To calculate the spring constant, you will need to record force and displacement. Place the end of the spring at the edge of the meter stick and attach the Newton scale to the other end. Stretch the spring to different lengths and record the reading on the Newton scale at each distance.
By using Hooke's law, you can solve for the K value of a spring. Using the equation force over negative displacement, input the data collected to calculate K for each trial. Then, average these values together to get the spring constant for this part of the experiment.
To calculate percent error, take the absolute value of the experimental spring constant subtracted from the actual spring constant and divide by the actual. In this experiment, we're using the value calculated from Hooke's law as the actual, then multiply by 100. While we have been using Hooke's law to understand the application of a spring constant, our studies of simple harmonic motion show that there are more ways a spring constant can be determined. The period of an oscillating spring can be solved by the equation period equals 2 pi times the square root of mass over the spring constant. We can solve for the spring constant if we know the period and mass. We used the motion sensor to calculate the period of various masses. The result we got from averaging the spring constant of each trial was a spring constant of 30.461. This result was compared to the traditional method of finding a spring constant, using Hooke's law where the constant can be determined by force divided by the negative displacement. When we used Hooke's law, we got a spring constant of 29.47. The 3.363% error shows that the method of using a motion sensor was accurate, and any slight discrepancy could be attributed to technological error.